We're looking at variation of density with water. So basically, let me put it to you guys in this way. Say we are looking at a temperature of the liquid to be T degrees Celsius. Now, temperature of the liquid post heating, it will change to T plus delta T degrees Celsius. So this is post, you switch this on and you start heating it. So you get to see bubbles and stuff. And yeah. So basically a liquid which was of this form, what happens to it? There is some increase in volume. Now, if I consider this to be V naught, the volume, this will become V naught plus delta V. Agree? Now the question is, if my mass is m naught over here and the mass over here is mn, that is nothing but m naught plus delta m, what kind of value will delta m take? Will it be a positive value or negative value? Actually neither. It's equal to 0. But why? Why is it 0? Think about it. I'm telling the mass of the liquid. Actually, I should not be telling that. If I tell that, that's the answer. So I'm going to start with the math. So as per law of conservation of mass, what we're looking at is m naught is equal to m nu. Both are equal. Why is that? As I mentioned, law of conservation of mass. That's it. Okay. So you cannot, we are not adding anything over here or removing. We are just letting it heat. You just imagine that. You're not letting it evaporate also. Or if you want to debate that, we might be evaporating, let's think that it's closed. So you can imagine that. So you're not letting the particles go away. So the mass will not change. So now my next question to you guys is, if the density over here is rho naught, this will be rho nu and given by rho naught plus delta rho. So my question to you guys over here is, will this value be a positive value, a negative value, or a 0? Okay, let me ask you guys this way. Next option is, will it be a 0 or a non-zero? 0 or a non-zero? This value will be, yes, a non-zero value. That is, what does it imply? This implies that density changes. Okay, yes. Good job. So let's move on. So let's figure out the density of the liquid, new density. So what should we use? Density is equal to, correct, mass by volume. So with this, we can move on to writing mass as V naught, right? Density into volume, and new density into new volume. So if we rewrite this expressions, so let me write it here itself. Rho n into V naught 1 plus gamma delta T. So V naught gets cancelled, and we have nu is equal to rho naught divided by 1 plus gamma delta T. This can be written as rho naught 1 minus gamma delta T. So some of you might have a question, why is that? So actually in exam, you just have to write using binomial, MINAL, right? Expansion. So this is, yeah. Nomial. MIAL. Okay. So this is binomial expansion using binomial expansion. This is a mathematical topic that you should have studied by now, I guess. If not, it's a very simple thing. So binomial expansion deals with expanding a plus b whole to the power of n. So as per that, what we are doing over here is, in this case, we are expanding a plus b whole to the power of -1. Okay, actually there's one more condition I forgot. So this formula is true, and 1 or rho delta t is a much smaller value than 1. Only then this works actually. If not, the expansion is altogether a bit longer, but it would be this shorter because of this fact. Okay, that gamma delta t is much smaller than 1. So I won't be able to explain much on this. You guys have to check the binomial expansion chapter for better understanding. Okay, guys. So this is a note. So in this case, it is 1 plus, let me just write this. Okay, so that would be your density. Basically, guys, obviously, if the volume increases, mass remains the same, density has to change. I just made it a bit longer video. It was just a 10 seconds statement.